Welcome to a new section on modules. As your programs grow, you'll need a way to organize your functions, variables, and classes into separate, manageable, and reusable files. In Python, this is achieved using modules. Modules are the fundamental way to structure your code and share functionality. 1. What is a module? Simply put, a module is just a Python file, a file with a py extension containing Python code. This code can be anything: function definitions, class definitions, or variables. Think of it like a toolbox containing specific tools. For example, you might have a module named calculations.py with functions for adding, subtracting, and multiplying. 2. Why use modules? There are two main reasons. The first is organization. Modules prevent your programs from becoming one giant, impossible-to-manage file. They allow you to logically group related code. The second is reusability. Once a function or class is defined in a module, you can easily use it in any other Python program you write without copying and pasting the code. 3. The import statement. To use the functions and variables defined inside a module, you must use the import keyword. When you run import module_name, Python finds that module's file, executes all the code inside it, and makes all its definitions available for use in your current script. To summarize, modules are the building blocks of large Python applications. They allow code to be neatly packaged and shared. Next, we will create our own custom module and practice importing and using the code we define inside it. Let's put the concept of modules into practice by creating a simple Python file and learning how to access its functions from another file. Join me in Lecture 14.02. Create a module and use it.
See you there.
Welcome back. Let's now put theory into practice by creating our own custom module. We will create two files, one file to hold our reusable code, and a second file to import and use that code. This demonstrates the core principle of modular programming. 1. Creating the module file. First, create a file named calculations.py. Inside this file, we define two simple functions, add and multiply, and a variable, course_name. This entire file, calculations.py, is now our module. 2. Importing the module. Now, in a separate file, say main.py, we use import calculations. This makes everything defined in calculations.py available to us. Crucially, when using the imported elements, we must prefix them with a module name and a like calculations.add or calculations.course_name. This prevents naming conflicts. 3. The output. The output confirms that our main.py file successfully accessed and executed the add and multiply functions, as well as the course_name variable defined in the completely separate calculations.py module. To summarize, we have created and used a module, demonstrating a way to organize and reuse code in Python. Our next lecture 14.03. Different ways to import. See you there. Welcome back. While the simple import module_name works, Python offers other ways to import code, allowing you to control exactly what is imported and what name it is given. We will look at 3 common import variations in this lecture. 1. Import all. As we saw, the standard way is import calculations. This brings the entire module object into your script and requires you to use the prefix calculations before calling any function. This is generally the safest way, as it avoids naming conflicts with functions already in your script. 2. Importing specific elements. The from module import element syntax allows you to import only specific functions or variables like add and course_name. Once imported this way, you can call them directly without the calculations prefix. This is useful when you only need a few items from a large module, but it carries a higher risk of naming conflicts. 3. Importing with an alias. If the module name is too long, you can use the import as syntax to give it a shorter alias. For instance, import calculations as calc. Now you use calc instead of the full name, saving typing while still maintaining the safety of prefixing. 4. Wildcard import. The from module import syntax imports absolutely everything from the module directly into your current namespace. While convenient, this is generally discouraged because it makes it very difficult to track where functions are defined and significantly increases the chance of accidental name collisions. To summarize, Python provides flexibility in importing. The safest is import module name, the most readable is import as, and the most selective is from import. Our next lecture 14.04. Use Math module. See you there. Welcome back. Having learned how to create and import our own modules, let's now start using Python's extensive standard library, a collection of built-in modules ready for use. We begin with the math module, which provides access to common mathematical functions and constants. 1. Importing and using constants. We start by using the standard import math. We can now access the mathematical constant pi as math.pi. Here, we use it to calculate the area of a circle. Notice that we use the module name prefix, math, which is a good practice for clarity. 2. Using basic functions. The math module offers many functions. Math.sqrt calculates the square root, and math.pow calculates one number raised to the power of another. You could perform these operations using basic arithmetic operators, but the math module ensures the highest precision and clarity for mathematical intent. 3. Rounding functions. The module also contains specific rounding methods. Math.floor always rounds a number down to the nearest whole number, making 14.7 become 14. Math.ceil always rounds a number up to the nearest whole number, making 14.7 become 15. These are precise tools for specific mathematical requirements. To summarize, the math module is crucial for any scientific or engineering application. We used it with the import statement. Our next lecture 14.05. Use random module. See you there. Welcome back. After the math module, we move on to one of the useful modules for applications that involve chance or simulation, the random module. This module allows us to generate pseudo-random numbers, which are essential for games, creating test data, and adding unpredictability to your programs. 1. Generating random integers. We import random. To get a random whole number, we have two primary functions. RandomRandRange works like the range function. It includes the start but excludes the stop value. Random.randint, on the other hand, is generally simpler for ranges because it includes both the start and the stop value in the possible results. Always be mindful of whether the upper limit is inclusive or exclusive. 2. Generating random floats. Random.random returns a random floating point number between 0, 0, inclusive, and 1, 0, exclusive. This function is often used as a base for scaling random values to any desired range. 3. Random selection. The random module also handles selecting from sequences. Random.choice returns a single, randomly selected element from a list or tuple. Additionally, random.shuffle takes a mutable sequence like our colors list and rearranges its elements randomly in place. This may be used for simulating drawing cards or reordering player turns. To summarize, the random module is your tool for adding dynamic and unpredictable elements to your programs. Our next lecture 14.06. Number guessing game. See you there. Welcome to our final project for this section, building a classic number guessing game. This project is a review, bringing together our knowledge of the random, module, loops, and conditional logic to create an interactive program. 1. Setup and generating the secret number. First, we import the random module. We then use random.random to select a secret number between 1 and 20, including both endpoints. We initialize the guess variable to 0, which ensures it is not equal to the secret number at the start. This allows our while loop to begin. 2. The main game loop. The core logic is a while loop that continues as long as the user's guess is not equal to the secret underscore number. Inside the loop, we take the user's input, convert it to an integer using the try and except block to handle errors, and then provide feedback using if, elif, and else. If the guess is too low or too high, the loop continues. 3. Winning the game. When the user correctly guesses the number, the while loop condition becomes false, and the program breaks out of the loop. We place the final congratulatory message outside the loop, as it only executes once the loop has successfully terminated, confirming the win. To summarize, we integrated several Python concepts into a practical and fun application. Our next lecture 15.01. List comprehensions. See you there.